Got a big math exam coming up? Or maybe you just want to sharpen your skills? Well, you are in exactly the right place. Think of this as a high-speed tune-up where we build your personal math toolkit one key concept at a time.
Yeah, we all know that feeling, right? When a big test is just around the corner. It can feel like a lot, but what we're going to do here is cut right through all that noise. We're going to give you the foundational tools you need to walk into that exam feeling ready. So, let's get started.
All right, first things first, part 1, the numbers foundation. Look, you can't build a house on shaky ground, and in math, that solid ground is understanding how numbers actually work. These are the core skills that literally everything else is built on.
So, our very first tool in the kit is the highest common factor, or HCF for short. Just like it says, it's the biggest number that can divide into other numbers perfectly with nothing left over. Now this is super useful for simplifying fractions, but also for real-world problems. Seriously, getting this down saves you so much time on an exam. So, the question is, how do you find it?
Well, a great way to start is with a factor tree. It's this visual tool that helps you break any number down into its prime factors. You know, those numbers that can only be divided by 1 in themselves. If you look at 120 on the screen, you just keep branching out, breaking it down, until every single branch ends in a prime number. These primes, they're like the basic DNA of the number 120.
Okay, so once you've got those prime factors for each number you're working with, finding the HCF is a really simple 3-step process. First, you just list out all the prime factors. Second, you look at both lists and circle the factors they have in common. And finally, you just multiply those common factors together. Boom, that's your HCF. It's a foolproof method. It works every single time.
Okay, this next one is a classic trip-up, so listen close. The difference between square roots and cube roots. On the left, you see that any positive number has 2 square roots, a positive one and a negative one. Why? Well, because a negative times a negative gives you a positive, right? 5 times 5 is 25, and negative 5 times negative 5 is also 25. But cube roots are different. As you can see on the right, any number, positive or negative, has just 1 cube root. Getting that little detail right can be the difference between a right and wrong answer on the exam.
All right, let's move on. Part 2 of our toolkit, the language of algebra. You know, if numbers are the bricks, algebra is the language we use to write the blueprints. It's all about using symbols and letters to talk about numbers we don't know yet.
First step, we gotta get the vocabulary right, because these words are not the same thing. An expression, well, it's just a chunk of math with no equal sign. A formula, that shows a relationship between different things, like area equals length times width. And an equation, that's what has an equal sign and some unknown you need to figure out. Knowing which one you're looking at is step 1.
So how do you actually solve one of these things? The whole game is to get x, or whatever letter you're using, all by itself on one side of the equal sign. And you do that using inverse operations. If a number is added, you subtract it from both sides. If it's multiplied, you divide both sides. It's just like a balancing scale. Whatever you do to one side, you have to do the exact same thing to the other to keep it level.
And you know what's really cool about algebra? There's usually more than one way to get to the right answer. Check out Polly and Theo here. They have a formula and need to find W. Polly likes to rearrange the formula first to get W by itself, and then she plugs in the numbers. Theo, on the other hand, plugs the numbers in right at the start and then solves for W. Guess what? Both methods work perfectly. The real key is finding the one that makes the most sense to you. Okay, time to pack the third part of our toolkit, geometry. This is where math gets really visual. It's where we take all those number and algebra skills and start applying them to shapes, lines, and angles, the world we can actually see. So, a huge piece of geometry is understanding what happens when you have a line, we call it a transversal, that cuts across 2 parallel lines. The second that happens, it creates a whole bunch of angles that have very special, very predictable relationships with each other. And if you know just one of them, you can usually figure out all the rest. And here it is, your secret weapon, your cheat sheet for these rules. Just look for the letters in the lines. Vertically opposite angles make an X shape, and they're always equal. Corresponding angles make an F shape, and they're equal too. And alternate angles make a Z shape, and yep, you guessed it, they're also equal. X, F, Z. Seriously, burn that into your brain for the exam. Here is another absolute must-know rule, this time for triangles. If you just extend one side of a triangle, the angle that's created on the outside,
The exterior angle is always equal to the two inside angles at the opposite corners added together. This is one of those little tricks that shows up everywhere in geometry problems.
Okay, home stretch. Time for our final section, where we're going to add a couple more essential tools to our kit. We're going to do a lightning round on a key data concept and then finish up with fractions. Let's do this. First, let's talk data. Population versus sample. What's the deal? It's pretty simple, actually. The population is the entire group you care about, like every single student in a school. But since you can't talk to everyone, you take a sample, which is just a smaller, manageable group that's chosen to represent the whole big group.
All right, let's tackle fractions and decimals. When you turn a fraction into a decimal, you've got two main types. A terminating decimal, well, it terminates. It just stops. It has an end. Like 1/4 is exactly 0.25. But a recurring decimal, that one goes on forever, repeating the same pattern over and over and over, like 1/3.
So what if you have a bunch of fractions and need to know which one's bigger? How do you do that? The trick is to get them all on a level playing field. And we do that with a common denominator. That's a number that all the bottom numbers can divide into. Once you convert them all so the denominators are the same, all you have to do is look at the top numbers, the numerators. The bigger the numerator, the bigger the fraction. It's that simple.
And just like that, we're at the end of our high-speed review. We've gone through core numbers, algebra, geometry, data, and fractions. You've got the tools. The foundation is there. Now the only thing left is to go out and start using them to solve some problems.
So I'm going to leave you with one last question to chew on. We've added a whole bunch of tools to your kit today, from finding the HCF to solving for x to using those angle rules. But out of everything we talked about, which one do you think is the most powerful? And more importantly, why? Which one opens up the most doors in math? Give it some thought. Thanks for joining me.